There is a widely held belief in the tech community that simply switching to Linux is enough to protect your privacy. The idea has spread across forums, YouTube channels, and tech blogs for years. Ditch Windows, install Linux, and you are free from surveillance, telemetry, and corporate data harvesting. It is a comforting narrative, and there is a kernel of truth to it, but the full picture is far more complicated. A default Linux install is not automatically private. Linux gives you the tools to be private, but whether you actually are depends entirely on your configuration. That distinction matters enormously, and understanding it is the first step toward building a system that actually protects you. The myth persists because Linux genuinely is better than Windows in several important ways out of the box. It does not come loaded with the aggressive data collection that Microsoft has baked into Windows over the years. There is no mandatory telemetry pipeline feeding your hardware information and usage patterns back to a corporation whose business model depends on data. The kernel itself is open source, meaning anyone in the world can inspect it, audit it, and report problems. The community that maintains Linux operates under fundamentally different incentives than the companies behind proprietary operating systems, and that shows in how the system is designed. These are real advantages, and they are worth acknowledging honestly. But the gap between better than Windows by default and actually private is vast, and most people who switch to Linux never close it. They install Ubuntu or Fedora or Linux Mint, browse the web the same way they always have, use the same applications they always used, and assume the Penguin logo on their desktop is doing the heavy lifting. It is not. Linux gives you outstanding raw security primitives, privilege separation, open patching, and no auto-execute behavior, and then hands you the controls. Whether those controls are tuned properly, whether SSH is hardened, whether kernels are patched, whether audit logs are reviewed, that is entirely on you. The same logic applies to privacy. The operating system gives you the foundation. What you build on that foundation is your responsibility. One of the first places that default Linux privacy breaks down is in the applications that ship with most distributions. Firefox, the browser included with Ubuntu, Fedora, Linux Mint, and countless others, is a genuinely good browser with strong privacy values at the organizational level. But it does not ship in a privacy-hardened state. By default, Firefox collects telemetry data in two main categories: interaction data and technical data. Interaction data includes metrics such as the number of open tabs in Windows, the number of web pages visited, the number and type of installed Firefox add-ons, session length, and interactions with features offered by Mozilla or third parties. Technical data provides information about your Firefox version and language, device operating system and hardware configuration, memory, and basic crash and error information. None of this is malicious in intent, but the point is that it is happening without most users realizing it on an operating system they chose partly because they wanted more privacy. Fixing Firefox is not complicated, but it requires knowing that the problem exists in the first place. The primary telemetry toggle lives in the privacy and security section of Firefox settings under the label Firefox Data Collection and Use. And unchecking that box is a necessary starting point. More thorough hardening requires going into the about.config interface, where dozens of individual telemetry preferences can be disabled. Settings like toolkit.telemetry, .enabled browser, .new tabbage, .activity, stream.telemetry, and data reporting.health report. Upload enabled all need to be set to false for a thorough cleanup. Users who do not want to perform this process manually can instead switch to LibreWolf, which is a community-maintained fork of Firefox that systematically strips out all telemetry, data collection, and phoning home features present in standard Firefox, including Pocket integration and sponsored content recommendations, and ships with a powerful ad and tracker blocker uBlock Origin pre-installed, defaulting to privacy-respecting search engines like DuckDuckGo. For those who want maximum anonymity, the Tor browser routes all traffic through the Tor network by design, making it the only credible choice when the goal is genuine anonymity rather than simply reducing tracking. The browser is only the beginning of the application layer problem. Many programs that Linux users install and use daily phone home in ways that are not obvious. Snap packages on Ubuntu connect to Canonical's servers. GNOME's optional user data sharing, crash reporters, and popularity contest tools all communicate outward. Even individual desktop environments have varying relationships with telemetry. The broader point is that every application you install on a Linux system is a potential privacy surface, and treating the operating system as a privacy guarantee while ignoring what runs on top of it is a fundamental mistake. Privacy on Linux is not a feature that comes installed. It is a practice that requires active maintenance at every layer of the software stack. The network layer is where many Linux users are most exposed, even those who think they have done everything right. When you connect to the internet from a Linux machine, Your internet service provider can see every unencrypted DNS query you make. DNS, or the domain name system, is the mechanism that translates human-readable website addresses into the IP addresses computers actually used to connect. Every time you type a URL into your browser, your machine asks a DNS server for the corresponding address, and by default, that query goes out in plain text to whatever DNS server your ISP has configured. DNS servers are given by your ISP, which offers them a list of every website you visit. This compromises anonymity in a fundamental way, and it is a problem that exists regardless of which operating system you are running. The solution on Linux involves configuring encrypted DNS, either DNS over HTTPS or DNS over TLS, which wraps your DNS queries in encryption so that your ISP cannot read them in transit. This can be configured at the system level through Network Manager or System Resolved, or at the browser level, where Firefox and other modern browsers support encrypted DNS natively. The key is to actually change the DNS resolver away from your ISP's default to a privacy-respecting alternative such as Quad9, Cloudflare with their privacy policy, or ideally a self-hosted resolver that you control entirely. Simply installing Linux does nothing to change this behavior. Without explicit DNS configuration, every website you visit is visible to your ISP in plain text, on Linux exactly the same as it would be on Windows. VPNs are often discussed as the solution to network privacy, and they are genuinely useful tools, but they introduce their own complications on Linux. While consumer VPN apps are GUI-driven on other platforms, Linux often requires CLI configuration, system integration, or editing configuration files. Even with a properly configured VPN, DNS and WebRTC leaks can still expose your real IP address if the setup is not handled carefully. A WebRTC leak occurs when your browser uses the WebRTC protocol for real-time communication features, and in the process reveals your actual IP address even while a VPN is active. This is not a Linux-specific vulnerability, but Linux users who rely on VPNs for privacy without testing for these leaks are operating under a false sense of security. For high anonymity, you need to enforce DNS over VPN, restrict WebRTC to relay only, block UDP outside the VPN interface via firewall, and tunnel IPv6 fully or disable it at the OS level. IPv6 is a particular blind spot for many Linux users. Most home internet connections now support both IPv4 and IPv6 simultaneously, a configuration called dual stack. Many VPN clients are configured to tunnel only IPv4 traffic, which means that while your IPv4 address is hidden behind the VPN, your actual IPv6 address may be leaking directly to every website you visit and every service you connect to. By 2026, global IPv6 adoption has surpassed 44 to 48% of all traffic, and many VPN setups are still built around IPv4 and simply overlook IPv6 unless specifically configured to handle it, meaning some apps keep communicating via IPv6 outside the VPN tunnel entirely, quietly and without error messages. On Linux, disabling IPv6 system-wide can be done through sysctl configuration, or it can be tunneled through the VPN if your provider supports dual stack connections. The firewall situation on a default Linux desktop is better than many people assume, since most distributions do not run many network-exposed services out of the box, but it is still worth configuring explicitly. UFW, the uncomplicated firewall, is available on Debian-based distributions and provides a straightforward interface for setting up rules. The basic approach is a default deny policy on incoming connections, allowing only the specific ports that your legitimate services actually need. A default deny inbound policy using UFW or firewalled, opening only the ports your services genuinely need, is one of the most effective and immediate hardening steps available on any Linux system. This alone will not make you private, but it substantially reduces the attack surface of your machine and closes pathways that data could leak through. Kernel-level privacy and security hardening is a topic that goes deeper than most desktop Linux users ever venture, but it is worth understanding at least in outline. Linux ships with powerful mandatory access control frameworks, including SE Linux and AppArmor. These tools work by defining policies that restrict what individual processes can do, even if they are running as a normal user. Mandatory access control can contain damage even when something is exploited, because code execution does not automatically mean full access. Done properly, it turns many intrusions into dead ends. On Ubuntu and Debian systems, AppArmor is installed by default but needs active profiling to be effective. On Fedora and Red Hat family systems, SE Linux ships in enforcing mode, which is one of the reasons Fedora is often recommended for users who want a more out-of-the-box hardened experience without needing to do everything manually. The choice of Linux distribution matters more than most new users realize. For maximum security, Cube's OS compartmentalizes everything into isolated virtual machines, offering unmatched protection, though with a steep learning curve. For daily use, Fedora with Linux in enforcing mode offers excellent security with mainstream usability. For hardened Debian-based systems, KickSecure adds security features without breaking compatibility. Tails is a distribution designed specifically for anonymity, running entirely from a USB drive without leaving any trace on the host machine and routing all traffic through Tor by default. Honix takes a different approach, running as two virtual machines where one acts as a gateway, routing all traffic through Tor, and the other is the workstation you actually use. These are not distributions for everyone, but for users whose privacy needs are serious rather than casual, they represent approaches that address privacy at the architectural level rather than as an afterthought. Metadata is one of the least discussed but most revealing forms of information leakage, and it is one that a default Linux installation does nothing to address. Even when the content of your communications is encrypted, the metadata around those communications, meaning who you talk to, when, for how long, and from where, can reveal an enormous amount about your life, your relationships, your habits, and your beliefs. This is the kind of information that intelligence agencies have said is often more useful than the content of communications. Addressing metadata leakage requires thinking carefully about your entire digital behavior, not just which operating system runs on your laptop. Using Signal for communications, avoiding Google services, using pseudonymous accounts where possible, and routing traffic through Tor when metadata sensitivity is high are all practices that complement a hardened Linux installation. Disk encryption is another area where default behavior on Linux varies considerably and where many users fall through the cracks. Most Linux installers offer full disk encryption as an option during setup, using LUCAS, the Linux Unified Key Setup. Many users skip this step because it is optional and because they do not think about what happens to their data if their laptop is stolen or seized. Unencrypted Linux installation is completely open to anyone with physical access to the machine, regardless of how strong your login password is, or how carefully you have configured your firewall. The boot partition, the home directory, the entire file system is readable by simply booting from a live USB and mounting the drive. Full disk encryption with a strong passphrase is one of the most impactful single steps a Linux user can take for data privacy. And yet, it is something that needs to be set up at installation time and is not enabled by default on many popular distributions. The browser fingerprinting problem is also something that Linux alone cannot solve. Even if you are using an encrypted VPN, a hardened browser, and a privacy-respecting DNS resolver, the combination of your browser version, screen resolution, installed fonts, time zone, language settings, and dozens of other parameters can be combined into a fingerprint that is unique to you across websites, allowing tracking even without cookies. This is a sophisticated surveillance technique that has become widespread because it works regardless of whether users have cleared their cookies or enabled private browsing mode. Tools like the Tor browser address fingerprinting by standardizing what the browser reports across all users, making every Tor user look identical from the outside. For users who do not want to use Tor, Firefox with a carefully tuned about config and extensions like uBlock Origin and Canvas Blocker can meaningfully reduce the fingerprinting surface, though it can never eliminate it entirely. The honest summary of where Linux stands on privacy in 2026 is this. It is a genuinely better starting point than proprietary operating systems. Not because it is automatically private, but because it gives you the tools, the visibility, and the control to actually achieve privacy if you are willing to do the work. The corrected mindset for any Linux user serious about privacy is that Linux gives you outstanding raw security and privacy primitives and then hands you the controls. Whether those controls are tuned properly is entirely on you. A default Ubuntu installation with Firefox out of the box, no encrypted DNS, no VPN, no disk encryption, and no firewall rules is not a private system. It is simply a less invasive one. The difference between those two things is significant, and closing that gap requires deliberate action across the browser, the network layer, the kernel, the file system, and your own daily habits and digital behavior. None of those steps are beyond the reach of a motivated user, and many of them are not even technically difficult, but they all have to be taken consciously because the default state of Linux will not take them for you.